Hello everybody! This is an exciting video. We're going to start talking about how do we get things to be plotted in Matlab. If you're used to things like Desmos or even a graphing calculator, what you might expect is very different than how Matlab actually ends up plotting things. So the main idea is to plot a function in Matlab. We pass it a list of x coordinates and we pass it a list of y coordinates, and then it plots those points and it connects them with lines. So you can imagine if I only have a couple points, the lines are going to be very jagged looking when they get connected, and the more points I give it, the lines get shorter and shorter, so the plots look smoother. So that's enough of me just talking. Let's look at help for plot. So let's see kind of what the documentation returns. So this is a lot. Let's not worry about any of it except for this first part here that says plot x comma y. So this plots vector y versus vector x. So we're going to pass it a list of x coordinates, a vector of x coordinates, a vector of y coordinates, and it's going to plot those for us. So let's try it out. Let's say I want my x coordinates. Let's say that these are equal to, I don't know, let's do 1, 3, 5. And let's say that my y coordinates are, let's say 1, let's do -6, and maybe 9. So I have these two vectors representing x and y coordinates. And now remember the notation is we do plot, and let's do v comma w. I'm going to press return. And we can see here, oops, we don't want this interaction yet. We'll learn about that later. We can see, okay, we get this plot, and I want to be able to view v and w at the same time. So let me make this a little bit larger for us. All right, I hope that's clear. So we have v and w here in the workspace. That's where I'm going to be looking. So remember the first point we have, that's going to be 1, 1. So also another thing to get used to is these axes labels might be a little bit different than what you expect. So here's 1 and here's 1. So there's our point 1, 1. Then we have the point 3, -6. So here's 3, and at the very bottom of the y-axis there's -6. And our last point is 5, 9. So all the way up here. And this is also where you can see what I was talking about MATLAB kind of connecting points with lines. So we have these 3 points, and it connects from left to right, or kind of it connects in the order that we passed them. So we connect the first point to the second point to the third point with a straight line. So that's cool. What if we tried something like, so now plot, let's do w comma v. So now we're swapping kind of what were x and y. So now w becomes our x coordinates, v becomes our y coordinates. So again here. So now we have the point 1, 1. So that stayed the same. So here's 1, 1. Now we have the point -6, 9. Or sorry, -6, 3. So there's -6 and there's 3. And then we have 9, 5. So notice that this fails the vertical line test, so this is not kind of a function that you would have in a class like Math 13 or really any of your classes where you call a function a function. But what this highlights is that MATLAB can plot things that are beyond functions in some sense. So maybe another thing I want to show you is, okay, like we've plotted a bunch of points. How would we plot something like f of x equals x cubed, let's say? So what I'm going to do is let's select some x coordinates. So let's say I want to go from -2 to 2. And I'm just going to pick a couple points. So let's say -2, -1, 0, 1, 2. So these are our x coordinates. Now the y coordinates, so remember we're doing x cubed. So I'm going to cube each of these terms. So I'm going to say -2 cubed. What is that? It's -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. And now what I'm going to do is I'm going to do plot of v comma w. And okay, that doesn't really look like x cubed, right? And this goes back to what we were talking about, where the fewer the points you use, the more jagged it's going to look. And this is because it's just connecting a couple of points. So the philosophy is, if I want this to look smoother and more like x cubed, I need to include more points. Because the more points I have, the shorter the line connecting them. And if you have really, really short lines, from our perspective, that just looks like a curve. So how can we do that? Let's remember back to the video where I introduced linspace. So remember, I think I mentioned that this would be very useful for plotting. So here's where we're going to see it. So let's say I still want to go from -2 to 2. So linspace, -2, 2. And I want to have, let's say, 50 points. So these are our x values. Oops, and what did I do, or what was I missing? I really should have put a semicolon after, right? I don't want to see that. Now, one thing that I'm going to do is I'm going to make an error next. And the reason is that the error message is going to be very helpful for us. So let's say w equals, now remember, we want this to be the x values cubed. So what if I do something like v raised to the power of 3? So think about what might go wrong. So the first part of the error message is kind of explaining what's going wrong, but this last message here gives us a hint to what we want. So remember, v is this vector with 50 x values, it's 50 points, and we want to cube each one. And this last part is saying to operate on each element of the matrix individually, use dot caret, so for element-wise power. So what this is going to do is it's going to go through every entry of v, so this is our 50 points, and it's going to cube it, and that's exactly what we want. So we're going to do w equals v dot caret cubed. And now this gives us the cubes that we want. All right, now we're going to plot it. So remember, we're now plotting 50 points instead of just the couple that we had before. And we can see that looks so much better already. So using just 50 points, we're able to see something that looks a lot closer to what we would expect. All right, everyone, I think this is a good place to end the video. In the next video, we're going to talk about plotting a circle, and in the videos after, we'll talk more about how we can get multiple plots on the same picture. So thanks, everyone, and I will see you soon.